Hello, and welcome to this session on Oracle Machine Learning Office Hours Feature Extraction for Machine Learning 102. Marcos Aranzubia will be our speaker today and helping us with our mission to help people see data in new ways, discover insights, and unlock endless possibilities. So we'll have the upcoming session and then Q&A afterwards that we'll do more interactively. But if you have questions, meanwhile, during any part of the session, feel free to add questions of general interest to the Q&A, or if you have some other questions, you can submit those in the chat as well. The next session that we have is going to be February 23rd, next Tuesday, and this will be a hands-on lab using Oracle Machine Learning for Python on Autonomous Database. So you'll be able to get some first-hand experience with OML for Py, and we look forward to seeing you there. If you can subscribe to this session for next week, we'll get a sense of how many folks will be interested in that. There are a series of 6 labs that will take you through various aspects of working with OML notebooks with OML for Py, from the transparency layer all the way through to AutoML. So we look forward to you joining us for that. If you would like more information on the Oracle Machine Learning product suite, you can go to our website at oracle.com/machine-learning. And if you're interested in getting a free account of Autonomous Database to try it out, please go to oracle.com/cloud/free. And you can sign up for an always free account and start working with the SQL API today. And coming very soon, you will have access to OML for Py as well. And so the things that Marcos is going to be showing us today, as well as things that we've seen in past sessions in our Machine Learning 101-102 series, you'll be able to get started with that. All right, so without further ado, we have today's session on feature extraction for Machine Learning 102. And this is the 8th session in the series. We're focusing on explicit semantic analysis, talk about the benefits over LDA and the capabilities in working with text corpuses like Wikipedia. So to you, Marcus.
Thank you very much, Mark. Hello, guys. The idea today, as Mark was saying, is to talk about feature extraction, but in the context of explicit semantic analysis, right? So the last time we looked into what exactly was feature extraction, right? So for the 101 session, we looked into generally what that means, what kinds of components, and how do you do these things. We talked about feature selection, and then we ran through several different types of models. We talked about all of these algorithms, right? PCA, SVD, NMF, right? We did show a demo on those things. And then for today, the focus is going to be explicit semantic analysis. So the basic benefit, right, out of the essay is that it is more interpretable, that the latent Dirichlet allocation. And the idea here is that you will take text, right, individual words or a text or an entire, book, right, if you will, and all of those documents or text or phrases or words are going to have a vectorial representation, but that will actually be using a corpus, a document corpus, as a base, right, as a knowledge base. So when you think about what the essay is doing, it's actually mapping whatever words or documents you have into these a special representation, right, that it used for it using that knowledge base. So the idea is that you use a word, right, representing that as a column vector on the TF-IDF, right, the matrix. But the idea is that you have words, right, or string of words or documents. They are represented as centroids of these vectors, right, representing its own words. So what that helps you with is, for example, when you think about the Wikipedia, right, English Wikipedia, you then can probably map most of the general knowledge documents and papers and words and phrases, right, into something meaningful, right? So you have a certain semantic relatedness to um, these components, and they are very interpretable. That's the basic idea. The idea is that there are concepts there that were explicitly defined and described, right, originally by humans. And now when you take your document and you map it in there, you are going to get some of these concepts that make sense, right, that are relatable. So normally what you do that for, right, and why you use ESA for is typically to either do some explicit, topic modeling for text, or to compute the similarity, right, between documents and between mixed data, right? That's basically what you're trying to achieve with that, right? So a quick comparison, I don't want to go too crazy on this, but a quick comparison with Latent Dirichlet allocation is that in LDA, the topics discovered are latent, so they are not really super interpretable sometimes. And it really depends, but the main problem there is there are no really real names, right? You might have some abstract descriptions. You give meaning to topics, but the keywords extracted by LDA might end up with some definitions that are just based on keywords. So there are many times where you see that automatic extraction and it will not map to a very convenient English topic, for example, right? And then the topics are fluid, right? Because with LDA, when the training data changes, right, the topic changes. So the set of topics there is always changing with the data. So as you know, if your training data is changing for any reason, the model actually changes completely and you get different types of topics, right? So that's basically the experience. So on the ESA, the idea is that you have a knowledge base with topics that were defined by humans already, right? And again, Wikipedia is one of those things, right? But you can imagine for medicine, right? You have a specific set of knowledge base, that are based on just medical papers, right? Or something specialized on electronics that those are specifically built for an industry. So that kind of ability helps that, right? Finding the right topics of interest and the tasks, right, that you have at hand. So you have that ability to really identify very specific topics by modeling those right directly. So, and also you can combine multiple knowledge bases, right? So that helps as well. So in general, then a deeper view, basically, then you are mapping, as we mentioned before, right? The ESA model itself, right, is basically mapping, right, that those words into these concepts, and the index that it gives you back will incorporate those weights, right, that will reflect what is the distance between those documents, for example, right? So it will help you identify that distance between documents and things along those lines. For something like Wikipedia, right, as we were talking about before, it's a great source, right, for general purpose. It's very much widely used. Now, it's also something that would require you to do some work, right? Think about what you see on Wikipedia normally. You might have a lot of things that might not have relevancy for you. Sometimes you have the reference, some links, right? Some other things that might not be useful. So when you want to use Wikipedia for ESA, the normal process, right, actually requires some tweaking, right? So for that, we at Oracle, we developed and worked on our own Oracle machine learning in database Wikipedia model, right? And that specific model requires a lot of different things. So we take a load from Wikipedia dumps, for example, and Wikipedia dumps are available and they're open, right? So anyone can go in and get them. You can take them. They are XML, compressed XML files, but they include a lot of things, right? They have a page, they have lots of additional tags, they have content, they have a lot of things that are not visible on the website that are, of course, behind the scenes visible, right, in the HTML. So there is a lot of cleanup, right, that needs to be done. So the first step is doing that and cleaning the pages, right? So there's a page filtering there. And again, this is what we do, right? I'm not saying this is the best practice. This is the best practice we have come up with and our development team has been doing. So other companies, other people might want to do it a little different, but these are the ways that we've found it to be most useful. So we clean up and collect the pages that describe concepts, right, and more general knowledge about subjects. So there is a lot of parsing and stripping HTML tags, partial tokenization happening. We remove special characters, right, because if we're working with the English language, right, we drop words that have numbers in the middle or special characters in the middle. So we end up with a set of category pages and a set of article pages, right? That's basically what we end up with. So that's the collection we start with to process. Then we proceed to use something called Doc Store that the Oracle Labs created. That's a tool that allows us to do some cleanup on top of that. So we now at that point split the XML dumps into individual entities, and then we include article and category pages and ignore all the other types of pages because there are other things. So the outcome of that process is you end up with this tab separated value pages file. You have a tab separated value page with crosslinks, and then a page by category as well. So we end up with those three files, right, or large sets of files outside. And then finally, for loading that into the Oracle database and creating the ESA model, then we are doing a lot of different things. We are, at the end of the day, we want to limit, right, that model, right? You can think about the amount of information that is in there that might not be really useful as a general concept, right? So we want to try to get the ideal set of a balance between how much of a filter we can do versus the loss of resolution, right, on what we're looking at. So at the end of the day, we do some computation there, check all of these pages that have crosslinks. So if they have more crosslinks than less, then they are probably more important. So we end up reducing that to retain the pages that are more general and describe concepts. We do filter out, references and links, sources, further reading, because sometimes those things might not necessarily have to do with the concept that you have on that specific page, right? So the final ESA model that we build, it's based on a limit of 200,000 features, and we retain the top 1,000 features on that feature vector, and they result in something around 20 actually I think it's 21.7 million records, and it's 800 megabytes in size. So having said that, we then use that model today at Oracle. Not only we use it inside some of the demos that I'm going to show you, but also it's used inside the Oracle Machine Learning Services, a component that is coming up, that is today in a limited availability, and that I'm going to do a quick demo to you guys on that. So having said that, there is a place where you can download the ESA model today in the Oracle OSS. If you go into the oss.oracle.com/machine-learning, you can download version 1 of that model. That version 1 works with database 12c. For the current release, we have a version 2.0 that works with the Oracle database 19. If you are curious about it, if you want to do some testing, you can ping me. We are going to expose that newer version on the oracle.com/machine-learning in one of the sections there, right? I think we have a download section where we're going to expose that there. But this is just to say we created that guy. Now, again, this is an Oracle machine learning in database model itself, right? So if you download it, you have to install it in an Oracle database and use the Oracle machine learning with it. And I'm going to, again, show you guys a demo of that in action, right? Now, I talked about Oracle Machine Learning Services. I'm not sure many people know exactly what that stands for or what it works, but the idea here is that you have the new component that is available in or the autonomous data warehouse is going to be available for any autonomous database, actually. And the OML services, or Oracle Machine Learning Services, it's basically giving you functionality to support model deployment and basically model lifecycle management. So create model endpoints on REST. Through the REST APIs, you can enable storing and scoring of Oracle machine learning models, right, in database models, but also the classification and regression using third-party Onyx models. So you can have your own favorite scikit-learn, TensorFlow, any other package that normally generates Onyx models. And if you have that metadata and that model, we can register the model with OML services and score it. But we also include the proprietary cognitive text capability, right? So we include that in English, French, and Spanish, and we allow you to do some topic discovery, keyword summary, sentiment, and feature extraction, right? So we have that, again, based on the same Wikipedia knowledge base, right, using embeddings behind the scenes. And finally, we do allow you to also do image. So you can actually take an Onyx image classification model that you built on something like TensorFlow, and we can deploy that model and score it as well. And that all is included with your Oracle Autonomous Database. There's nothing to install or nothing to do anything special. It is, again, today in limited availability, but once you have it enabled or once it comes out as GA, hopefully perhaps in the next quarter, you will get access to it, and all you need is your user and password from an Oracle Autonomous Database. So the top portion of these call, right, where you have your REST client, your curl or whatever you're using, you can just pass your user and password to that /OML users on that autonomous database data center that you have, your PDB, and you will get a token. And once you get that token, now you can then talk to the bottom portion, which is the /OML mod, and then you do the get, post, delete, whatever you want to do with the OML services. And so for that to work, you just have to pass the token, and then you pass the actions or whatever you want to do. So as a complete overview of what OML services do, these are all the different endpoints and capabilities. So for repository, right, you can store model, update model, get a list of models and things along those lines, right? And then deployment, so you create a model endpoint, you get model endpoints details, you can get the open API specifications, you can get the Swagger file, things like that. And then on the right-hand side, we have a specific things that we do with the cognitive text. So those are, I'm going to focus on those guys just because, again, we're talking about ESA today, and we're talking about these kinds of models. So I'm going to focus on that. Okay. So the idea today then is we're going to take a look at feature extraction 102 on the OML notebooks, right? So we're going to see how to use ESA on OML for SQL and OML for Python. And then I'm going to move into the OML Services cognitive text via REST. I'm going to be using Postman for that. Basically, the idea here then is I'm using the Oracle machine learning, right? So this is the Oracle machine learning notebooks. And right here then, what I'm going to do with this guy, right? I'm going to have a few sections. So the first section is going to be a very basic usage of ESA without a specific topic model, right? So I'm going to show you how to use your own, create your own mini model, and then map your own features, right? So this is very, very simple. And then I'm going to show you the Wikipedia model and how do we do that? How do we check that the model is there, right? And then we can create a proxy for that model from Python. And then we're going to see the basically examples using Python and SQL, right, for all these things. So features for words, features for phrases, and then document similarity, right, on phrases and on long phrases as well, right? So basic things first, right? Initialize environment. Again, this is just the typical import pandas. I'm not going to use plots, so I don't need really matplotlib, but I'm doing the import OML. And then on the right-hand side, this is something you would have used if you were running outside of the autonomous, but we don't need that. So very basic usage, right? So on the left-hand side, you can see that I have a very, very basic training data, right? And my training data is I'm going to create a data set with comments. So I'm adding all of these comments there. And then I have a second column that's called year. And then I have a third column that's called ID, right? So it's just very simple, seven rows. I got some names here, some phrases, right? And I got some years. There are strings, right? But years related to the years in numbers here. And then I have an ID that is numerical, right, in there. I am defining my train data and my test data. So because of the split, so I'm splitting that into 70-30. And then I'm using 30% for test, right? And then 70% for training. Now, very simply put, you always need a policy file, right? So this is a policy file. And so the policy file here, what I'm going to do here then is I'm going to drop if I have an existing policy file, right? So let me adjust that. So I can drop that if the policy file with that same name exists, because I'm creating now my new policy, right? My new ESA policy. So now I am creating that policy, and I need to create that before I start adding that to my model, right? So the second step here is then create that model, right? So I'm going to delete if any ESA basic model exists before, right? And then going to give it the settings, right? So the settings here is the important thing that's going to make changes to your model and type of model. So what I'm saying here is the minimum number of documents is 1, minimum number of items here is 1, just to make, because my model is so tiny, right, that I want to make sure that this makes sense here, right? And then the context settings, right? So I'm going to add that policy name, and I'm going to give it the policy name that I'm using, right? And then what is the token type that I want, right? So I want to use stamps here. So once I have that, I'm going to establish that ESA mod is actually an OML ESA model. And then I'm going to do the model fit, right? I'm going to fit that model. This is the model, the train, right? That model, this is the model name and things like that, right? So now I can check basically the model that was used. So again, just for checking, right? Train data on the left-hand side, the test data is on the right-hand side, right? So, and then basically I'm going to verify the model details. So if you just write the model name itself, right, in Python here, you're going to get then the information about the model, right? It's saying it's a feature extraction model. And these are the settings, right, that were used, right? So there are top 10, 1,000 features. This is the default, missing values automatically managed. So you have a lot of basic information. And then it's using, I have 4 attributes, right? And then it tells you the features, right? So these were the features discovered by the ESA on the data you had. So there is Africa, there's AIDS, there's planning, war, year, and then you have the attribute values for year, right? That you found there as well. So that's the way it describes the information there. So now I can check the ESA features as well. On the right-hand side, you can say just dot features and you call it. And I'm just giving it around 4 so that coefficient looks a little better. And then again, this is the same listing of features you're going to see here, right? The same listing you would see there, right? On just a better way to visualize it, right? In Zeppelin, you guys remember using that z.show function, right? So that the output does not look like text. You can basically look at that as a table. That looks a little better. So to predict then a feature vector on test data, right? So let's run that. And what happens here now is when you look at the prediction, right? I'm doing a dot predict, so I'm doing a prediction with that data. Now you see what happens here. And I'm asking for the return of that model, not only to be the predicted feature, right? The feature vector, but I'm also asking, please show me the ID and comments, the original ones, right? So I can see I have the ID, I have the comments, and now I have the predicted feature ID that is based on the ESA model, right? This feature ID was not created using the test data. It was created using the original data. So these guys saying, okay, these are the feature IDs that are most likely to resemble, to have something to do with your text over here, okay? All right, and then on the right-hand side, I'm saying, you know what? I want to get, don't just give me the feature ID, right? I want to see the top 2 features. So I use a transform. So that means I want to take the top 2 features and I want to see their coefficients if I map the original test data into the space that I have on my ESA. So that's basically what it's doing. It's taking that same text, right? NASA announces major Mars rover finding. And then you have a top feature is 3, like we showed here. But now, because you're asking me to map it for you, I'm going to say the second, right? The second top feature here is 2. And this is the coefficient there as well. So you start seeing the information, right? The ability to map that data that is coming into the new space and find topics and relevant topics, right? So that's basically the idea here. Now, you can also use that for similarity, right? So you can do a feature compare because we are able to map the text into those features, right? Space. Now you can then compare. So I'm now saying, okay, let's compare these comments. I want to compare comments A versus comment B. So because you passed the compare column comments, it's going to compare all to all. So it's going to compare this guy versus the second one, right? And it's going to give you a similarity, right? So it's going to say, hey, this guy looks very, very similar, right? 0.94, because it's rovers and then, NASA and Mars again, right? But then NASA and roadblocks for AIDS, it doesn't look like a lot, right? 0.87. But again, this is not taking into account the context, right? You got to remember the only context it has is that there are these things there as well on your original text, right? So we're going to see that with Wikipedia, this is going to be much more precise, of course. Right? And then on the right-hand side, again, we're using the same thing, but this time we're using now comments and year. So I'm adding now another fact to that comparison. I'm saying I want to check that the year is also part of that comparison. So now when it compares those two things, even though they are the same comments, right? But because I'm taking year as well, right, into account, you can see that the similarity now changes, right? Because now this guy is looking at the years that this data was coming from, and you can see that the NASA Mars Odyssey versus the major finding here, right? You can go up back to your data, and then you can check that the rover was 2017, but the Odyssey was 2018, right? And then for the model itself, because you use that in your model building, it's going to say, yeah, that sounds like a different thing, right, for it. So there is some more increased difference, right, that's going to find instead of that similarity that you had before, right? And now it's saying that the roadblocks for age is more similar to the Mars Odyssey. Again, because it's looking at, it's going to be looking at the years, right? And you see now it's comparing all of these two guys, but also the year, right? And because the years are the same, then it gives it a better approach, right? It tells it it's more similar. So and that was the idea with the comparison, right, of that. And then you can also refit the model. So now I'm saying I want to use the same model I had before, but I want to actually change that model, and then I'm going to change the threshold for the ESA values, and then I'm going to increase the features to 2, right, and the top end features to 2. And then with those settings, you're now restricting more the model, right? So the model is down here, it's built, you can see that the attributes, but now look at this, right? So now the feature IDs, instead of containing all of that information, right, that you had before, now it only contains AIDS, Mars, and AIDS in a different year. That's it, right? And then when you try to score with it and do a feature comparison, because you only have like 3 different things, it's going to be giving you similarity in thirds, right? So that is, again, just to show you that the settings would affect the type and quality of the model as well. Okay. Now, in addition to that, of course, normally we would like to clean up. So if you're done with this, you could clean up your ESA policy, right, and drop that policy so that that's cleaned up from your environment. But that's, again, an optional, right? If you found the model that works for you, you can keep it there, right? Now, finally, using Wikipedia, right? So there are a few blogs already out there, right? So Charlie posted the first one on the Wikipedia model and how it's made available for text processing. He points out to how to use it in SQL. And then Mark created these 2 next posts on using the Wikipedia with R. So this is the text analytics and the ESA for text analytics using Oracle R Enterprise on Oracle database on premise, right, and in DBCS as well. And then so what I'm showing down here now is how to use it in SQL side by side to Python, right, on our side. So you can, first things first, normally you would delete existing policies and create new policies. This is not going to work if you run this thing immediately and then try to use it right away. So this is something you can probably, you will probably run it outside of OML notebooks, or you'll run it previously before you go into using it, right? This is part of the setup. So if you look at the setup over here in any of those blogs, you're going to understand this is part of that setup, but I'm just adding it over here for information purposes. But basically, you will need to create a preference called Wikilexer, set an attribute for it with language, and then add that policy name, right, and create that policy name to use those things. These were pre-built with that model. Then because it's a large file, right, it's an 800 megabyte model object, right? So it's not something you want to load from a notebook or something like that, right? It's a large process. So normally you would already have loaded that model, so it will be included in SQL, right? If you think about in database, it's going to be there already. Now, how do I map an existing model that is an existing ESA model in my database to Python, right? To use that as proxy, because before we just created a model from scratch, right? Now on here, this is what we're going to do. We're going to actually use something like this, right? So we're going to do oml.esa and then call the model name, and then you say the specific name of the model name that you want to use, right? If the model was loaded to a different user, then you will need a sysdba to grant execute on your model, right? Either to you or to a public, and then in SQL, right? And then you can then map that into something like this: model name equals, and then model owner equals, right? Because then only one person needs to load this gigantic model inside the environment, right? Now, basic things. So we want to check whether the model is available, right? So if the model is available, then it's going to show up as this wiki model. You're going to see that wiki model is a mining function feature extraction. And this is the algorithm, ESA. It's a native model and the creation date, right? And then we're going to create that proxy object, right? If you recall, that's what we did, right? oml.esa model name equals wiki model. So now the ESA wiki mod object in Python is pointing to that, right? And then we're going to check, you got to be careful with this, right? And delicate. We're going to check the first 1,000 rows of the 21.7 million rows of features. So I'm doing a had 1,000 on top of that features of the model, right? And doing a round 4 to round the coefficients here. And you can see, feature ID. So there's a lot of details about all of these context, right? So there are a lot of different themes and concepts, right, that you're going to see on the left-hand side. And there are many, 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 many different types of words that are available and there are part of that, right? So that's basically that portion. Now, on the right-hand side, what I'm doing here is I'm actually wanting to check all parameters. Now, you will have to have a decent amount of power. So I'm using, I guess I'm using high here because I wanted to see the entire model. So it comes back, but it takes, 2 minutes and 40 seconds to show, because it is trying to explicitly show to me the entire thing. So it shows me the model, right? So you can see the model, you can see that, top end features, the threshold, right? And then you can see the max features. Remember, we talked about the 200,000 features, right? Minimum documents 5. And then you can see now the name of that, the attribute name, and then you can see all features. Now, of course, it starts on the 0, but it ends up in the 21,750,650 with that, right? So again, this is a large model, so you got to be careful on how to, you don't want to plot the entire thing or list the entire model, right? But this is the easy way to work with it. So on the left-hand side, I'm going to be working with SQL. On the right-hand side, I'm going to be working with Python. And basically, this is it. So on the left, then I want to say, show me what are all the things related to bank, right? I want to see how does just the word bank map in this Wikipedia model. And it shows up in all of these different things, right? These are the different feature IDs that you find there with their values, right? And same code, exactly the same thing. I'm going to push a pandas data frame. There's a single column text, right? And with a single row that is bank, the word bank. And then I'm going to do that transform on that. And it's exactly the same data, right? And that's what I'm expecting, right? So the results have to be identical, right? Because you're working with that same word, bank. Now, the interesting thing again is that the left-hand side is SQL and the right-hand side I'm using Python. So you can use, both language, you're going to get the same exact result, right? Second step, let's take a look at the word NFL games, right? So those are two words, NFL games, and I want to check what shows up in my Wikipedia. And then I can see the different components here, right? You get from NFL International Series, National Football League, Thursday Night Football, things along those lines. And the same thing is going to show up for the Python execution as well, right? So that's going to be the same components, right? Then we continue on. Now we add a little more text, right? So we give it a longer text about the planet orbiting another star, right? And things along those lines, the solar system. And now you start getting that information. Solar system, planets beyond Neptune, planetary system, exoplanets, right? Again, exactly the same thing here. I'm doing exactly the same text. All I'm doing is I'm pushing a text with the same information here, and I get my transforms, right? So again, the code is going to be the same, right? A little more info on dietary, right? Dietary and health. So nearly 70% of Americans say they're careful about what they eat. I can't say I'm one of those. And then you get all of that information about obesity and healthy diet and health. Same thing is going to happen here on the right. Obesity, healthy diet, right? Health as well. Now, we're going to get a longer text now, right? So now you're going to say, okay, but how long can I go? Well, there's not really a limit, on probably just the size of the column on an Oracle column, right? 40,000 characters or so, I don't know. And a blob, you can go even much larger. So you write a large amount of text here, and you're going to get those types of components and scores. And same thing is going to happen here with the same component. Now there might be a slight difference in the scores, and this is basically caused by these double quotes. Here is a double single quotes that in SQL is the standard. In Python, you probably would not use that. You would avoid it. So I'm going to find a way to escape those and then try to check whether it's going to be a little better, right? But then they are very, very similar, but you can see that they start changing all the way here on the fourth numerical value, right? So that's, again, a small detail, but you're still looking at the entire text, right? So you can also compare strings, right? So far we were mapping and checking for context, right? But now let's compare strings. So first strings, what we're comparing here is a street versus avenue, right? So street versus avenue in the Wikipedia context has a reasonable similarity, right? 0.215 here. And the same similarity is going to show up here on the right-hand side, right? Street versus avenue. Now, if you try to compare street versus farm, thank God the similarity is much lower, right? So it's 0.0123, right? And same thing is going to happen on the right-hand side. So, and here I'm passing, you see that what I'm doing is on the SQL side, I'm passing using street as text and using farm as text. While on the right, I'm creating a pandas data frame with the column name text with 2 rows, right? That's basically the way we are processing that. So simple text about golf. So I'm comparing PGA Tour golfers in South Africa versus Nick Price won the 2002 MasterCard Colonial Open. So you got a similarity, a more decent similarity. Same thing here with the Python code. And then now I want to compare golf and football, right? American football. So now you get a 0.004 similarity, right? Because from a quarterback into a PGA Tour golfers, then you get actually nothing to do, right? Very, very, very much a small one. Now, when you can add, again, larger texts, right? So you have a NASA Perseverance Mars rover, right? Then this is happening actually in a couple of hours. the Perseverance is going to land in Mars, right? They're expecting that, so that will be something interesting to watch. And then compare that with the SpaceX, right? Delivering segments to the Moon Orbiting Gateway space station, and there's a decent similarity, right? I mean, this is NASA. There's space missions and things along those lines, right? Same thing with the text on the right-hand side as well. Now, if I take that NASA rover news and check against one of the tennis champions, right, Naomi Osaka, which she just went into the semifinals yesterday, I think, after beating Serena Williams, then the similarity is much lower, right? This is really very, very little to do, right? Now, this is then the way to use that component, right? So you're using that so far into that process. Now, when we want to use something else, we want to use, as I mentioned before, we were going to use Postman, right? So in Postman here, when I look at Postman, basically what I'm doing is the first things first, right? So normally I have to get a token. So I send a request using my, as I mentioned before, my user and password for my database, right? This is my my current data center, right? So I'm in San Jose. And then this is my tenancy. This is my database name. So if you have your user and password, you get back an access token, right? All of this thing, this entire phrase. Now, with that access token, you can do all of the other things you can do in OML services, but I'm going to focus on the cognitive text, right? So if you basically push that as my token, right? My authorization token now, I'm going to access again San Jose. Look, that this is OML mod v1 cognitive text. There's nothing else. This is a straight link out to that. And you're going to get something like this back, right? Normally in curl, you're going to get your REST API endpoints. So keyword, summary, sentiment, features, right? And I just created a visualize to make it easier, but cognitive text components, again, keywords, right? Summary, you get similarity and things like sentiment, right? So real quick, keywords. So then to access that, I can send a text to my cognitive keywords. It will require my unique authorization. That's my unique token, right? That I have gotten before. And now I'm gonna want to check the top 5 keywords out of that text. So this is again a service coming with Autonomous Database, right? It's available in Autonomous Database, and for any Autonomous Database user, you'll be able to use this directly. You'll be able to call this and get this process done for you. So you'll send a text, and this is a REST API, right? So you send a text, you get these keywords here, right? And again, I improved the visualization of that just to make it easier. So these are the keyword results for that text, right? Same thing is going to happen with summary. So I send that to the summary endpoint now, right? And then I get the top 5. So I get the top 5 sentences back, right? If I visualize it, they show back, show a little better, right? So the weights of the sentences and the summary of that. Sentiment analysis as well is available. So I send the text and I get back a sentiment, neutral, negative, or positive, right? Again, we can look at that in this way. And then the topics, right? So we were talking about topics discovery, the top 5. I get the top 5 topics related to that, right? So I have things like scalability, Oracle database. I have Oracle Corporation, machine learning, analysis of algorithms, right? And then finally, similarity, right? So if I take these 2 topics here, I have the text like that, and then I want to probe this small portion of text. And then it's going to tell me, okay, this is a similarity, right? So if I visualize it, the similarity for machine learning algorithms, right, is going to be exactly that. And finally, you can search for the features as well, right? So you can send a text and then it's going to actually map that text into the Wikipedia features. It's going to return to you the numerical features, the 1,000, or actually in this case, I think it's a little more than 1,000. It's closer to 2,040 something features that are unique features that we map for you. So any text you send, you're going to get back the exact weights to help you with that. Now, as I mentioned before, this is also available in Spanish. So if you take, you just change the language here, you say language is Spanish, you put the text in Spanish, and you're going to get, keywords, right, in Spanish. You're going to get same thing, summary topics in Spanish, right? You're going to get similarity as well, right, in Spanish. So that's basically the idea here. And then French is also available in here. So both are not available for sentiment analysis, Spanish or French, but they are available for all the other components here. So keywords. So I got my keywords here in French, right? And things along those lines, right? And similarity and things like that. So we're closer to the top of the hour. As always, more information on the oracle.com/machine-learning. And I'm going to open up to Q&A. I know Mark answered a few of the questions here. If there are any questions you guys want to type in the Q&A section, we'll be more than glad to answer.
Yeah, great. Well, thanks for that session, Marcus. That was really great. So just a couple of the questions that we did cover, one had to do with the whole notion of concepts, and the one person wasn't clear on that early on. Do you want to say a little bit more about the concepts, Marcos?
All right, yeah. So when you build the ESA model, right? When you build the ESA model, what it does is actually it will create a vector of the most important words or the most important concepts that exists there. Now, Wikipedia, because of that, Wikipedia also has a concept specifically built in, right? So when you say, I want to talk about machines, then Wikipedia will have, okay, are you talking about a machine in an industry? Are you talking about machine learning algorithms? Are you talking about, whatever machines you're talking about? So Wikipedia does have those points where you have each page for a different concept. And those concepts were defined by a human, right? By a human being. So same thing is going to apply to any other things in life, right? If you're talking specifically only about, say, musical instruments, right? Or headphones. And then you can say, well, you have planar headphones, you have dynamic headphones, you have electrostatic headphones. What kind of headphones are you talking about? That might not be, relevant to you, but it is relevant to people wanting to learn more about headphones, right? So at that point, it is something that those concepts would be used, right, by your model if you allow it and you train your model with those things in mind. And then you can, of course, tell it to restrain the number, right, of those and tell it to make sure that you're only using the most important key ones, right?
Okay. Another question came up is, are there any plans to separate OML services from autonomous database from the user experience standpoint? Can you use it with OCI auth token versus the autonomous database token?
Right. That's a great question. I don't think we have that right now planned because the Oracle machine learning components as a whole are part of the autonomous database, right? Including the OML services actually is used by AutoML UI, which is also upcoming, to deploy models, right, and manage models. So it does require the autonomous behind the scenes for sure. At least for the time being, we don't see a way to decouple or detach that for now.
All right. I don't see any additional questions here. So unless there are some last ones, thank you again, Marcus. It was a very interesting and exciting presentation.
Thank you very much, Mark. Thanks everyone. Stay safe and See you guys next week.
Okay. So long.
Bye bye.